More yen. Well, that's the way we say hello in Luxembourg. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics. Now, children, for a little while, let's imagine that we are at this place and we are having our class here. So, this is the Upper Shore Natural Park, Osling, Luxembourg. At the heart of the park is the Upper Shore Lake, which is the largest reservoir of drinking water to Luxembourg and provides to 70% of its population. Here you can take kayak or solar-powered boat rides to see wild and beautiful birds, small welcoming villages, rolling hills, and bask in natural serenity where you can reflect and revere. Here you get to have a feel as if this is a picture which has been brought to reality. Make sure you actually be to this place, although at this time you're with me in this place, and have mum and tart and apple pie, which is really mouth-watering. Make sure also to tell all the people of Luxembourg that you get to meet more yen. In this note, children, I'm again going to say more yen, but at this time it is going to be to equation of a straight line. First, we'll be discussing few basics of two-dimensional quadrant geometry. We will look up the different type of lines. Then we will talk about the equations and the terms which are related with it, and after that we'll be discussing an interesting sum which will give you an edge if it comes in an examination. So children, let's get started and let's discuss some basics of two-dimensional quadrant geometry. Now children, when we talk about two-dimensional, it means that it has to be along two axes. That means there has to be an x-axis, there has to be a y-axis, and both of these axes are perpendicular to each other, and both of these axes make a plane or make a surface, right? So let us say now that we make our horizontal axis, our x-axis, to be, say, something like this, right? And then let us say we make our y-axis, the vertical axis, which is perpendicular to the x-axis, say something like this, right? So this, children, is our y-axis and this is the x-axis. Now we can be having straight lines which are in three forms. That is, a straight line can be one such which is parallel to the x-axis, right? Remember, its equation is given by y is equal to b, right? There can be another straight line which is parallel to the y-axis, something like this, and its equation is given by x is equal to a. Then in the third case, you can be having a straight line which is neither parallel to the x-axis nor parallel to the y-axis and is a oblique line, right? So when you talk about this third line, that is the one which we actually are going to consider for different equations which are possible. Now, a few things about this line. Let us say that we have a point on this line which, say, is some x1 comma y1, and let us say we have another point on this line which is, say, x2 comma y2. And now children, if we are to find out the slope of this line, which means we want to find out the gradient of this line, then that is given by a formula that is represented by m. So m actually gives you the gradient, which is also known as the slope. And when you have 2 points on a line, then you find the ratio of the difference in the ordinates and divide it by the difference of the abscissa to get the value of m, which is the slope of the line. Now remember here, children, when we talk about this line is one which obviously will be inclined with the positive direction of the x-axis at a specific angle. So normally what we do is we call this angle to be theta, and this actually is the inclination of the line. Now, the mathematical definition of inclination is the angle which the straight line makes with the positive direction of the x-axis in the anti-clockwise direction above the x-axis. I'll quickly repeat. When we talk about the angle which a straight line makes with the positive direction of the x-axis in the anti-clockwise direction and above the x-axis is known as the inclination of the line. Right? Now when we have the inclination of the line, then again we can find out the gradient, and then that is given by tan of this angle of inclination. Right? So these are the two ways by the means of which you can find out the slope or you can find out the gradient of the line. Now if we've got to find out the equation of the line, then we normally find it out by some ways. The first way is we talk about the slope intercept form. Now this is y is equal to mx plus c. Now let me quickly explain to you what all these variables are. Y and x are actually the infinite xy coordinates which are possible on the line. Right? So if you talk about this point can be having a different y coordinate, and if you talk about another point, this point on this line can be having another y coordinate. And as this line is to move infinitely on the xy plane, so thus there are infinite y coordinates. Similarly, there are infinite x coordinates. Obviously, when with what x coordinate which y coordinate comes, that depends upon how the line is inclined with the positive direction of the x-axis. Now here when we talk about this m, we've already discussed it. This is the slope of the line. The new thing is, what is c? C, children, is the y-intercept. I'll explain it to you. So Mohi, here if we talk about the y-intercept, it is actually the distance where the straight line has cut the y-axis from the origin. Right? So here, children, we will quickly mark. If you talk about the point of intersection of the straight line with the y-axis, it is this. We can name it to be, say, some p. And if you talk about this point is actually the origin. That is the point of intersection of the x-axis and the y-axis. So what is the y-intercept? The y-intercept is the distance of the point of intersection of the straight line with the y-axis taken from the origin. Right? So as one point is O and the second point is P, so OP will become the y-intercept. Now children, next we talk about another form of a straight line. So a straight line can also be written in the 1 point form, right? And the 1 point form goes like this. Obviously, in order to write it in 1 point form, you should be knowing a point on the line which, say, is some x1 comma y1. So it's no more a variable, it'll be now just like a constant, that is minus 3 comma 4, where x1 is minus 3 and y is 4. So the equation of the line is y minus y1 is equal to m times of x minus x1. Right? So here, children, next what we do is we should be knowing the slope of the line, which is m. We should be knowing a point x1 comma y1 on the line. Then the 1 point form can be applied to get the equation of the line, and this will be the equation of the line. Now next, after this, children, we have the 2 point form. The 2 point form is pretty close to what 1 point form is. The only thing is we do not even have the slope. And as we know that we can find out the slope or the value of m by finding out the ratio of the difference in the ordinates with the difference of the abscissa. So this is what we apply here. As such, here the equation of the line will be given by y minus y1 is equal to y2 minus y1 divided by x2 minus x1, and this is multiplied with x minus x1, right? So this, children, is the 1-point form. Okay, I'm sorry, it's the 2-point form, where it almost resembles the 1-point form. The only thing that is different is for slope we have applied the formula, as we know 2 points on this line. Thus this gives you the equation of the line in 2-point form. So all of this that we discussed, I'll just quickly discuss so that if there is any doubt withstanding, all of that will get cleared. So here, children, we are talking about 2-dimensional quadrant geometry space. So we have one line which is the x-axis, the straight line which is horizontal, and we have another straight line, the y-axis, which is perpendicular to the x-axis and vertical. So the space in between both of these axes is the surface, which is the xy surface or the xy plane. Now in this plane we are going to talk about different points which will give us a coordinate geometry idea about different points, different figures which can be formed in that space. Now at the moment we are going to talk about a straight line. A straight line, as you know, is the join of any 2 points, right? So there is a point, say, which is x1 comma y1, and there is another point, say, which is x2 comma y2, and let's say that they have coordinates given and their names be, say, some a and point b, and thus AB line segment can be produced on either side, right? And this is the line which can be having some equation. So this line, children, is a oblique line. That means it is neither parallel to the x-axis nor is it parallel to the y-axis. There can be a line which is parallel to the x-axis and its equation is y is equal to b. There can be another line which is parallel to the y-axis and its equation will be x is equal to a, right? So when we have such sort of lines, then we require to find out the equations also. So as we already know the equations of lines which are parallel to x-axis or y-axis, for the oblique lines we have the following ways of finding out the equations. The first, children, is the slope intercept form, where y is equal to mx plus c gives you the equation of the straight line in slope intercept form. Now here m is the slope of the line, that is, it is the gradient of the line, which can be found out by 2 ways. One is if you find out the ratio or the difference in the ordinates to the difference of the abscissa, you will get the slope of the line, which is also known as the gradient of the line. So this, children, is the formula. After this, if you require to find out the slope, it can also be found out by another way. If you know the angle which the straight line has with the positive direction of the x-axis in the anti-clockwise direction and above the x-axis, then this angle is known as the inclination theta. And now if we find out tan of this, so tan theta also gives us the slope of the line. Now after this, children, if we require to find out the equation of the straight line in y is equal to mx plus c, one thing that is not known here is c, the y-intercept. So what is it? When a straight line cuts the y-axis at a specific point, say P, then the distance of this point of intersection with the origin is known as the y-intercept, and here it's been marked with c. So OP is actually c, which is the distance where the straight line has cut the y-axis from the origin. Jessica, clear? Okay, now after this, children, next we now talk about the 1-point form, which is whenever there is a straight line on which we know a point x1 comma y1 and we also know the slope of the line, then its equation can be written in as the 1-point form, that is y minus y1 is equal to m times of x minus x1. So here, children, what we do is knowing the 2 points x1 comma y1, we just have to substitute their values, and as we already know the slope, we have to keep its value, and then we will write the equation of the line in the general form. That is, we'll bring everything to the left hand side, all to the numerator, and that is all, right? So ax plus by plus c is equal to 0 is the general form in which generally the final answer is expected. Okay. Yeah, Jessica, don't worry, when we'll be discussing sums, I'll tell you how to bring the normal equations which are formed to the general form. So now children, next we have the 2-point form, where if we know 2 points on the line like this, right, then first we can find out the slope of the line by finding out the ratio of the difference in the ordinates to the difference of the abscissa. And then in place of m that was required in 1-point form, we can just substitute. So the equation becomes y minus y1 is equal to y2 minus y1 upon x2 minus x1 times of x minus x1. So this, children, is the 2-point form, although there are more forms which are there for straight lines, but at this moment we will restrict our discussion to just these forms of the line. Now children, coming over to the sum. So this is the sum that I like you people to try, and after that then I'll be discussing the sum with you people. Make sure to actually try out the sum. If you're studying offline, make sure that you have first learned all the formulae and then you're trying out the sum. Okay, children, so let's look up this question. In this question, we've been given a straight line makes positive intercepts on the axes whose sum is 5. So let's quickly first make our x-axis and our y-axis, that is the xy plane, right? Remember, the plural of axis, axis, is axes, axes, right? So here, children, we now have the y-axis, say something like this, and after that then we will be having our x-axis, the horizontal axis, say something like this, right? Remember one thing, never draw a line over the already drawn line. That will cause some confusion. Draw it between the lines, and thus the line that you made will be more visible. Okay, so this is the x-axis and the y-axis, and let us say that we talk about our required line to be, say, something like this. So Jessica, tell me, is this the line that we are expecting? Is it possible that the line that we are talking about in the question, which has positive intercepts, this to be the line? Don't know, I'll tell you. If you talk about this point, this is the point where the straight line has cut the x-axis. So if you find out its distance from the origin, it will be the x-intercept. And as you see, it is on the right hand side of the origin, so it will be positive. However, if you talk about the y-intercept, that is the distance of the point of intersection of the straight line with the y-axis from the origin, you find that it is below the origin, or in other words, it is negative. So this case cannot be considered. So if you talk about other cases, we can now talk about the case that is, say, something like this, where we can have the x-intercept as well as the y-intercept both to be positive, and that is possible if we have the line like this. So here you see that the x-intercept is positive, that is the distance of the point of intersection of the straight line with the x-axis having its distance from the origin, right, is positive, as the distance is on the right side of the origin. Similarly, if we talk about the y-intercept, it is also positive because it is the distance between the point of intersection of the straight line with the y-axis from the origin, right? As such, here these 2 points have positive distances from the origin. As such, they can be said to be positive intercepts. Now we've been given that the sum of both of these intercepts is 5. So if, say, we talk about the x-intercept, right, to be say some A, and if we talk about the y-intercept to be say some B, then we can write the coordinates of both of these points, which say are some P and Q. So Q will now have the coordinate to be A comma 0. That is because this point is on the x-axis, and as such its y-coordinate will be 0. Now if we talk about the point P, then we know that its x-coordinate is going to be 0 and its y-coordinate will be B, because the point hasn't been able to move on the x-axis. So these are the coordinates of the point P and Q, that is the points of intersection of the line with the x-axis and the y-axis. Now children, there is one thing which has been given to you, and that is the sum of the intercepts. So we've been given that A plus B is equal to 5. As such, from here we can say that B will become equal to 5 minus A, and children, we can consider this to be our first equation. Now after this we talk about the rest of the question. Here, if the line passes through the point minus 3 comma 4, so let us consider that this is that point which say is some point R. Oh, we've been given this to be point P, so we have to consider this to be point P. So our point P can be considered to be point B, say, right? Okay, so this point P has the coordinates of minus 3 comma 4. Okay, so the x coordinate is minus 3 and the y coordinate is 4. Now you see that there are 3 points on this line L1. So if you require to find out the slope of the line, then you know that slope is given by y2 minus y1 divided by x2 minus x1. So if you talk about the slope of the line L1, then it can be found out by finding out the slope between the points PB, BQ, or probably PQ. And let's now sort out the simplest ones. So let's talk about P and the point Q. So we can say MPQ, that means the slope of the line PQ that is getting formed, will become equal to slope of the line PB which is getting formed. Obviously that will also be equal to slope of the line BQ that is getting formed, right? Because if you talk about this line, or if you talk about this line, or if you talk about this line, they are one and the same. So when we talk about the line PQ, then again by y2 minus y1 upon x2 minus x1 we can find out the slope of the line. So slope of the line L1 will now be given by 0 minus 4, as we are considering the coordinates of the point Q to be x2 comma y2, right? Then in the denominator we will have the difference of the x coordinates, that is the abscissa, so it will become equal to A minus minus 3, right? Further, now we write the slope for the points P and B, right? Now children, here there is one thing which can be done. As we know that we have the value of B to be 5 minus A, we can substitute it here. So as such the point B actually becomes 0 comma 5 minus A, so that we just have one variable, that is A, and then we can solve out that variable. Okay, now children, we can find out the slope of BQ or probably PB, doesn't make a difference, right? So let's talk about the slope of PB, right? And the slope of the line PB will become equal to 5 minus A, considering it to be the second coordinate, minus 4, and in the denominator we now have 0 minus minus 3, right? Now children, we will solve this, as this is just an equation in one variable, that is A, right? So we can very easily find it out, and after we have A, very easily we can even find out B. So this can further be written as minus 4, which is divided by A plus 3, and that can further be written as 5 minus 4 is 1, so it will become 1 minus A, and in the denominator we have 0 minus minus 3, that means it will become equal to 3. So here further we will have minus 12, right, which will become equal to A plus 3 multiplied with 1 minus A. Now next children, what we do is we can now write this to be minus 12 is equal to the product of both of these binomials, which will give us a minus a square plus 3 minus 3a, right? So for the children here, we can take the terms which are with the variables on the left hand side so as to make the term which is quadratic positive. So as such, here we have now a square, and then here the linear terms are a minus 3a, which will make it minus 2a. Taking it to the other side, it will become plus 2a. Then we have minus 12 on the left hand side, and when we take this plus 3 to the other side, it will become minus 15 is equal to 0. Now children, from this we have to get the values of a. Now we can write the product of the prime factors of the coefficient of the quadratic term and the constant term. So it comes to be 3 into 5. Now in this, if you write a square plus 5a minus 3a, so obviously that will give you plus 2a minus 15 is equal to 0. Now this is perfectly factorizable. That is because there are two terms which are positive and there are two terms which are negative. If there would have been three terms which are positive and one term which is negative, then it couldn't have been factorized. Okay, now out of the first two, you can take a to be common outside. Inside you'll be left out with a plus 5, and now here when you write a plus 5, this will go minus 3 times, which is equal to 0. As such, we can now take a plus 5 from this binomial common outside, and inside we'll be left out with a minus 3, which is equal to 0. Now as we can apply the zero product rule, so once we will have the value of a to be minus 5, and at the other time we will have it to be 3. Now Jessica, which is the value of a that we can take? A. Very correct. That's because a is positive. Remember, we'd been told that the intercepts are positive. So as such, the value of a is the x-intercept, and it is 3. Now we also have to find out the y-intercept, remember, and as the sum of both of these was equal to 5, so as such we can now say that the value of b will become equal to 5 minus 3, and as such it will become equal to 2. So thus we have the value of b, we have the value of a, right? And now whatever is required, we'll very easily be able to find it out. Now here let's look up. We've got to find out the equation of the line. So now as we have 2 points, very easily we can find out the equation of the line, right? So remember children, the slope of the line is 1 minus a upon 3, right? Which we can take it from here. We can mark this to be, say, some equation number 2, right? So here slope of the line will be 1 minus a upon 3. 1 minus a divided by 3, and as a here is 3, so we have 1 minus 3, which is divided by 3, and that becomes equal to minus 2 upon 3. So that then is the slope of the line. Now as we have points on this line, that is, this point will fall to be pretty simple, that is a comma 0. As a is 3, so 3 comma 0 will be a point on it, right? So here you will say a comma 0 or 3 comma 0 is on line L1, and therefore you'll be applying the 1 point form, and the 1 point form is going to be what? It is going to be y minus y1 is equal to m times of x minus x1. It was so good that with me the whole class was mumbling. That means by the time I gave you the formulae, you learnt it. This is what is required when new concepts are given to you. You should have learned them really well, because they get applied every now and then, and when you are learning it in class, that is the time when you are fresh. If you learn it then, it will be very well learned. The staler it becomes, harder it becomes to memorize, right? So always try and do your work early, right, so that you can learn easily, and when you learn easily, obviously you find the subject to be very nice. And in maths or physics, if you know formulae, then doing the sums or the numericals becomes a child's play. Okay, So here children, next what we do is we will now write the equation of the line, which will be y minus y1 here is 0. That will be equal to m, which we found out to be minus 2 upon 3 times of x minus x1, which is 3. So here children, what we do is, as I've told you, we've got to bring everything to the numerator and then everything to the left hand side to get to our final equation, written in the form of ax plus by plus c is equal to 0, which is the general form. As such, here what we do is we can now write this as y is equal to minus 2 upon 3, which is multiplied with x minus 3. Now in the next step, what we can do is we can cross multiply this 3 to the other side. And as such, here we will have 3y which will become equal to minus 2x plus 6, right? And thus we will now bring everything to the left hand side so that the coefficient or the number multiplied with x is positive. So as such, here we have 2x plus 3y minus 6, which will become equal to 0, and thus this is going to give us the equation of the straight line written in ax plus by plus c is equal to 0, the general form. So this is how we get to the solution of the sum, and children, this is the final answer. And I'm sure all of this must be perfectly clear, but even then I'm going to give you another explanation so that if there is any doubt whatsoever, all of that gets cleared. So in the question, children, you've been given that there is a straight line where you have the straight line cutting the x-axis and the y-axis in such a way so that the x-intercept and the y-intercept are both positive. So obviously this is the only line which is possible, because if you make it here, you will have the x-intercept to be negative. If you make it here, then you will have the x-intercept as well as the y-intercept both to be negative. And if you have the line here, then you will have the y-intercept to be negative. This is the only place where, that is the first quadrant, if you make your straight line, the x-intercept and the y-intercept both will be positive. So if you take this point to be one such whose distance from the x-axis is a, so the x-intercept becomes equal to a, because the x-intercept is the distance of the point of intersection of the line with the x-axis from the origin. Similarly, this distance can be considered to be b, which is the y-intercept, that is the distance that the straight line's point of intersection with the y-axis has from the origin. So as we talk about this point on the x-axis which has its y-coordinate to be 0, thus its coordinate can be written as a comma 0, and this point which has its x coordinate to be 0, as it is on the y-axis, it can be written to be 0 comma b. Now both of these points are, say, some b and q, and now we've been given another point p which is minus 3 comma 4, which is on this line, and then we've got to find out the equation of the line given that the sum of the x-intercept and the y-intercept is 5. So a plus b is equal to 5. So as such, here we can write the value of b to be equal to 5 minus a. Now if we've got to find out the slope of the line, we will apply the formula y2 minus y1 upon x2 minus x1. So here now, as we have many combinations which are possible, the point P is on the line, the point B is on the line, the point Q is on the line, and the line is the line L1. So the slope of the line L1 can be written either by finding out the slope between the points P and Q, or between the points P and B, or between the points B and Q, right? So here we choose those which require the minimum effort. So first we talk about P and Q, where we have zeros, so obviously calculation will be simpler. So we have 0 minus 4 divided by A minus 3, because we are subtracting, and then this number can be having any sign, and as it has a negative sign, so that's why its sign is going to be considered. Minus will become equal to plus. As such, it will become a plus 3 in the denominator, and in the numerator we have minus 4. Now here we talk about finding the slope of P and B, right? So for P and B, we now have B, which can be written to be 5 minus A. So as such, the point is 0, 5 minus A. right? So we have 5 minus a, which is the point whose y coordinate we have taken, and from that we're going to subtract the y coordinate of the point P. So this is 5 minus a minus 4, right? And then in the denominator we have the difference of the abscissa, which is 0 minus minus 3. So again, minus minus becomes equal to plus. So as such, you have plus 3 in the denominator, and in the numerator you have 5 minus 4, which is 1 minus a. Now when we cross multiply, we will get minus 4 into 3, which will become minus 12. That will become equal to a plus 3 times of 1 minus a. Now here, children, we have to multiply both of these binomials because we've got to factorize this equation so that we can get the value of a. So here we have a into 1, which becomes a into minus a, which becomes minus a square, 3 into 1, which becomes 3, and 3 into minus a, which becomes minus 3a. So bringing over these terms to the left hand side, we have a square, right, and minus 3a plus a will become minus 2a. Taking it to the other side, we'll have it to be plus 2a, right? And then we have 3, which is positive. Taking it to the other side, it will become minus 12 minus 3, that is minus 15, is equal to 0. Now children, we find that if we talk about the product or the prime factors of the coefficient of the quadratic term, which is 1, and the constant term, which is 3 into 5, right, we will now get here plus 2a, which can be written as plus 5a and minus 3a. So out of the first two in this polynomial, we can take a to be common outside, right, where we are considering this binomial. And then further here, when we write a plus 5, this is going to go minus 3 times because it will give you minus 3a minus 15, right? So further here, children, next what we do is, if we talk about this to be a plus 5 times of a minus 3, right, then it's equal to 0. As in this binomial now, a plus 5 is common, that's why you took it out, and inside you were left out with a minus 3. Now when a plus 5 is equal to 0, you get the value of a to be minus 5, and when a minus 3 is equal to 0, you get the value of a to be 3. So this is going to be considered to be a correct answer, as this is one of the intercepts, the x-intercept, and as both the intercepts were to be positive, so this is the only value that you can consider. Now as b is equal to 5 minus a, so it will be 5 minus 3, that is 2. So we also have the x-intercept, the y-intercept, right? So now children, we are to find out the equation of this line. Now first we'll talk about the slope in terms of one of the variables. We have the value of the slope of the line to be 1 minus a upon 3, right? So here we keep the value of a, which is 3, so 1 minus 3, that is minus 2 upon 3, becomes the slope of the line L1. Now we have many points on this line. Either we can consider the point P, which was given to us, or we can consider a simpler point. We can consider either a comma 0 or 0 comma b. There we will get to have 0, so that will make things simpler. So as such here, next now we consider a comma 0, as a is 3, so 3 comma 0 is the point which is there on the line, and we have the slope of the line, so we will use the 1 point form, and then we will get it as y minus y1 is equal to m times of x minus x1. Now here, as y1 is 0, so we have y minus 0 is equal to minus 2 upon 3, the found out slope, times of x minus the x coordinate, which is 3. Now further here, as we are to write it in the form of ax plus by plus c is equal to 0, so we can now cross multiply this. So we'll have 3y, and this minus 2 is going to get multiplied within. So we have minus 2x plus 6. Now we bring all the terms to the left hand side, so we have 2x plus 3y minus 6 is equal to 0, and children, this will become the equation of the straight line. So is everybody clear about this? The class in Luxembourg was good, right? Okay, next time I'll take you to some other place, and I'm sure we will have a nice class there. But the sad thing is, we do have to come back. Okay, have you already had that sweet dish that I told you? That's good. That's an apple pie. I'm sure you really must have liked it. Okay, children, so that is all that I have for you people in this lecture. I'm sure all of you people must have understood all that I taught you, right? If there was any doubt whatsoever, do write to me in the messages. I will try and make it clear. I can probably even call you in a live class and see what your problem is, right? Remember, children, there are these lectures which are there in YouTube which will provide immense help to you once when you've gone through them and done the sums well all on your own. If you require to see it once, do it once more. Further, if you find that you have more problems and you want to discuss it with me, then make sure you click in the link which will be given in the description, right? I will have a live class with you and I will make sure that your problem is lost. That is, it is no more, right? Meanwhile, if there are other things which you require, like there are certain topics in which you require courses or you require some notes, do let me know. My email ID will again be there in the description, right? And then I'll get back to you and help you out. So bye children, have a nice time. Bye.